Hello, everyone. I'm Kent, and this is Michael. And today we'll be presenting on how to interact with the chain. And yep, that's the title in full. So I'd like to start off by showing how to launch your own standalone node. And I mean, in theory, the network will already be running for you, so you don't have to do this. But in case you want to do some testing, this could be useful. And so, one thing is that, sorry, does this mic go through? All right. So one thing is that when you launch your node, you won't have the initial set of bonds. And this means that you won't be able to create a node that you can propose in. And this is, so what you need to do is just run the node once in standalone mode to generate the Genesis bonds file. And this kind of, it's a detail that you'll need to do, and it's hopefully a quirk that we can remove in the future. But for now, this is what you'll need to do. And here, as you can see, we're executing the run command in standalone mode. And standalone means that this node doesn't need to connect to anything else. And the data directory specifies where the bonds file will get placed in. And so once we get down here, we can see that up here it says where the mouse is. It says that we've created the validator. And these are the IDs of them. And so where they're stored, if you just Control-C the node, is in the data directory that we specified. So if you go in here, you'll see that there's a Genesis folder. And this contains a bunch of keys along with the bonds.txt file, which lists all those keys along with the weights of them. And so this, you don't really have to be concerned about what these are for identifying who you are as a validator. And if you're as a dApp developer, you don't have to be too concerned about this. But just for launching, you'll need to grab one of these keys. And so just copy this. Oh, enter. Cool. Sorry, I'm not used to this computer. Okay. So then we go back to the staging directory. This is where you would have your binary. We have it. We don't have it sort of globally linked, but if you have a Docker container, you should just be able to run rnode. And anyways,
this is from the tarball package for anyone who is interested in that. The running in different Debian versus Docker versus tarball, they all look a little bit different, but the command is basically the same. So here we're just calling this rnode script from inside the bin folder, and this comes directly out of unzipping the tarball.
Sorry guys, can you remove those two chairs?
oh, yes. I'm glad you pointed it out. All right, so now that we have copied the validator key, we can run it again in standalone mode. And we can pass in the validator private key right here. How do I paste on this? Okay. And then you have to specify the data directory if you did so before. And so then that will allow you to run the mode in not read-only mode. So then now we can actually deploy. Okay. Yeah, this is usually useful if you ever want to relook at your logs. Oh, yeah. Yeah. All right. So we're going to background this. And so now we're running the node. It's putting its output to log that out. And then so now we can just tail this file. And we'll see what the log is capturing. And so this is the same thing again, this time with the validator ID passed in. And so one thing you have to be careful of before you start testing is that the node has to get to this state called making a transition to approved block handler state. And if you don't let it load until there, then your deploys will just say the Casper instance is not ready. And so you just have to make sure you wait until here. And so once you do that, now we can actually deploy. And so, oops. Oh. All right. So today for a small demo, we are going to use, maybe I should present. We are going to use hello-world.row. So what this contract does is it just takes in a return channel, and we just send hello world on it. And so the commands down there are what we're about to run to execute this contract. And let me just kill the log once, and we just type it out. So, sweet. So here's the contract. It's in the same directory as our staging folder. And so we can just give it a run now. And so to do this, we want to, it's the same rnode command, but this time we put in deploy. Can everyone see back there? Is the font big enough? Okay, great. And then the deploy takes in the name of the contract. So if we enter here, then after a bit, it should give us a response message saying success, hopefully. Yes?
Yes. So one of the possible messages you could get back is syntax error, which means that you passed in some Rholang that didn't compile.
Can you give us a sense of what kind of error messages out of those did you do a syntax error?
Sure. So let's change this to have some kind of tilde here. Oh. Maybe this is fine. So I just modified a keyword. Hopefully that is all right. And so if we try to deploy with the contract keyword modified, you'll get unrecoverable syntax error.
It's also worth pointing out that if you look at the log, it gives you more information about that syntax error. So it tells you it's on line 1 at character 11. And it's a little bit unfortunate that this information doesn't come, here. But I looked into how you would actually have to change things to make that happen, and it's too much work. So just look at your logs. Line number in the log. Yeah. When you see a syntax error, the line number is in the log.
Yep. So yeah, this is character number 11, hopefully. Sometimes we're using BNFC and it's not too accurate about where the error is. It'll hopefully give an accurate range, but sometimes it's a bit off. And so we'll resave that. And well, we already have the contract deployed once now, so I won't repeat that. But once you deploy a contract, and what this does is it saves the deploy to the deploy history. Sort of, if you are familiar with Ethereum, what would be the mempool. And so in theory, as a dApp developer, this is all you really need to do. You just have to point a contract and deploy it against a validator's node. And the validator will hopefully take care of proposing it for you. And that's sort of the assumption right now in a lot of chains. And so, but for testing purposes, you're going to have to propose your own blocks. And this means you take all the transactions that are in your mempool equivalent and then put them in a block and then send them out to the network. And if you're only testing by yourself, sending it out to the network just means creating a block and adding it for yourself. And so the command for that is just propose. And if we hit that, then it'll spin a bit, and then it will say the block has been added. And so yeah, that now once you do that, you can confirm that your deploy actually went into the block with either the show blocks or the show block command. And if at any time you forget what these commands are, there is a help command that you can run. And so it should show here show blocks and show block. Yep. Is the, oh yeah, right there. So let me just give it a execution. So show blocks can take a bit right now. I'm sure some of you are aware, but we'll be fixing that soon. So here is the first block you'll see is the genesis. And you can tell because it says block number 0, but it also has no sender. And the block that we just created will be block number 1 if you just started the node. And so this is block number 1 here. And in here, you'll be able to see the hello world that we deployed. It's a bit messy, but let's see if we, yep, there it is, hello world. And so now what we can do is, so of course this output might be useful, but sometimes we want to actually just directly read off the chain without having to look through all these tuple space dumps that can be a bit messy. And so for that, let me go back to the slide. All right. Well, okay. So what we're about to execute is this listen data at name. And so what this command does is you pass it whether it's a public or private name. So right now we only really support public names, so you always have that -t_pub, and you pass it the channel that you want to listen on. And so one gotcha is that when you pass the channel, if it's just a regular public string, as we say, then you need to escape the quotes before it and then quote the whole thing. And this is because, well, the quotes for the whole thing are just to pass in the string, and then the the quotes inside are for the actual Rholang expression. What the compiler does, or sorry, the interpreter does underneath is it tries to make a Rholang ADT out of this, and so out of this string form. And so if you don't have those strings, it'll think that it is some variable, or I guess it will give you a top level free. Yep. And so
it's also pointing out that this you choose, right? This is a parameter we're passing in. We're deciding to listen on a channel that we've called underscore underscore out underscore underscore. And the reason we're choosing that is because on the previous slide, we defined a contract that is going to produce data on that name because we've passed in that as the return channel to our Hello World contract.
all right, so now we're going to give this a run. Whoop, what happened to? Oh, I see. Did I scroll too far? Yep. So, you want to? Sure.
Just so I don't have to type it out again.
Thanks. All right, so here we are now listening for out, and so it'll give this message saying starting to monitor for changes. So there is an underlying gRPC API which will directly give you back all the contents at out across all blocks. But what this sort of client does is that it takes that output and gives you diffs as the name changes over blocks. So you only see, you'll have to run this command first and then do your deploys and somehow change this name. And only then will you get output through this. And so yeah, you might want to background that, or you'll have to
Open another terminal.
open another terminal. That's probably an easy way. Oh. Yeah. So currently we're just yep, okay. So what we've done here is we've SSH'd into a different box, and we are now deploying to the local.
Yeah, it's actually the same box.
Sorry, yeah. Yeah, okay. So we're deploying to the same box, and if you were deploying to a different machine, you'll have to specify the gRPC host and the port for it, and that will sort of remotely push your deploy. And one thing to note is that we're sort of keeping this around, but in the future, probably node operators will rate limit you on this so that they don't get a whole bunch of requests remotely sent at them. But in any case, we've now deployed call hello.row, which is the contract you saw earlier, that sends to hello world the out name that we're listening on. And so what should happen is this call hello.row, the produced there should reduce with the earlier contract. And when that happens, there will be a change on the name out. And so if we hit propose,
It builds excitement.
all right. So we see here that we've created the block, and that the string hello world. Yeah, apologies. This is the ADT form, but we'll have it switched to something more user-friendly. But in any case, it prints out what is at that name right now as it changed. And yep, so essentially this if you want to listen, as you change this name, you'll see more output come down, sort of streaming in. And so yeah, we have an equivalent API or client operation called listen continuation at name, and that is for listening for any new contracts. So just, yeah, we'll show the help right now. Yep, so listen continuation at name. So it takes, again, the channel, and this time because contracts can be listening at, or contracts or fors can be listening at multiple channels. Yep. So this API does not change the chain at all. And oh, I see. So you want to be able to deploy without interact or like affecting the chain. Okay, so we don't have that yet. We do plan to implement that. Yep. And you'll be able to, or like the action is guaranteed to just call and then roll back on your local tuple space. Yep. And so now I'll pass it over to Michael Birch.
So Kent, can I ask a follow-up to that? So just to make sure I understand, so the current state is when you do a deploy, it's in a minimal kind of area until you do a compose. And so there's not sort of an ephemeral contract that you can run, a Rholang that you can run if you're going to subsequently deploy everything gets committed to the blockchain currently.
Yes, that is correct. You can use the Rholang CLI, but if you do that, you won't have all the previous state up to the chain. And so yeah, there's no really good workaround yet right now. Yep.
And then does that mean that even at a test contract that you run, if you deploy a revised Hello World, the previous one is gone essentially because it's at the same name, hello world.row.
So we never replace, or we never actually delete terms unless they reduce. So what will happen is you will have two contracts that are listening at that name. And so this is not an issue if your contracts are the same and they don't modify any state. But what you really want to do is use a registry so that you're guaranteed to not clash with someone else on that name. And Michael Birch will talk about that at the end of it.
Good segue into like my first bullet. My first bullet is this looks a little bit different with the name registry. So yeah, like Kent said, the name registry is going to address the two things you said. One is what happens if someone tries to deploy on the same name, and the other is about updating your own contract. The name registry will enable both of those features. So you'll be able to essentially create a name where your contract lives, and half of it will be made public. And so you can decide if people can send it messages or only read messages. Like it depends on if you're making a data feed or a contract. So, but the half that's public allows people to interact with it from off-chain. And then what's cool is that you can update the registry to then make that public half point to a different contract in the future. And so you can revise your contracts. And so the name registry doesn't exist today, which is why we're not demoing it for you right now. But it'll exist by the next time we release, so like mid-October. But the basics do stay the same here. So like the broad strokes of what we did look the same. It's just the syntax will look a little bit different. And yeah, Ken mentioned, we were only using public names and we didn't use unforgeable, but in principle that's also possible, but there's a little bug that makes it not work right now. That'll be fixed like really soon. So if you like building from dev, you can probably like do that next week and it'll be fine. And then the other thing here, and someone actually sort of had a question that alluded to this, is that querying for data is distinct from committing data to the chain, right? So the Hello World contract actually affected the blockchain, whereas the listen at a name thing was just watching the blockchain and seeing something come in. And the way the API is today, since it only watches for changes, it's not actually a very good API for just querying the current state. So if you wanted to do something like check the balance of a wallet, the current API isn't super good unless you're planning on doing a transaction, you know, sort of at the time. But we'll totally expose, probably in the next release, you know, APIs that are convenient for querying the chain. Do all those points make sense to people? Yes, all APIs that we expose will be through GRPC.
So the AST formatted output, if it's through GRPC, it comes back in protobuf? Then
Correct.
in RCON, are you going to talk about those things?
It comes back in protobuf. I wasn't planning on talking about it, but we can totally talk about it.
I'm interested.
Yeah.
When it fits in.
Yeah, let's do that right now. Let's talk about that. Because it is a good question. It's a very good point. So, like I said, it comes back in protobuf, right? So protobuf is platform agnostic and language agnostic. There are lots of APIs that people can use, so you can have it integrated with, you know, your own app in whatever language you're writing it in. People have had success with this, as far as I know, in both Python and JavaScript already, which I think are probably the two most common languages people will want to use anyways. Yeah, do you want to?
Yeah, so if you actually look currently in the RChain repo, let me just get out so this is, if you clone the repo, you'll probably get this. It's sort of used to you looking at IntelliJ, but yep. So what you'll see here is a bunch of projects or modules that we have, and so one of them is sort of this experimental node client, and what this node client does is it tries to interact with all the APIs that we showed earlier using Python. But what all the client calls that we were showing, they were sort of wrappers around the GRPC API written in Scala. But this time, like what these files, what I'm about to show you, what they show is a Python wrapper around the GRPC calls. And so if you look at, for example, Casper.py, you'll see that we have this text. Let's see. Why is? Oh, it's fine. Yeah. Sorry, that's just comments. You can read the comments above. But what this does is it creates a GRPC service stub and what a mess. Sorry, but it creates a Flask app that essentially exposes two endpoints. One of them is show block, and then the other one is show blocks. And essentially, you just make the call, and then it goes into the Casper block query. This is the underlying gRPC API name for show block, and it will return the result back to the Flask app as JSON. And so the way you generate these Casper message gRPC wrappers is, or sorry, gRPC clients, I should say, is they're auto-generated off of the proto file, and so they look kind of like auto-generated code. And yeah, I guess you can't see that either. Sorry, but this is for any language. You can just go on the tutorial for protobufs and their usage, and the Google page will have instructions for that specific language on how to generate these equivalent sort of client wrappers. And what you need to do is you need to look at it's under the models project, and models project will have source, main, protobufs. And so here we define all of our gRPC API calls. So at the top, we have all our protobuf messages, but at the top we have here, under the deploy service flag, we have all of our underlying gRPC calls. The show blocks we showed today, that's bottom, third from the bottom, fourth from the bottom, and then the listen for data at name and continuations, those are at the bottom. And when you do a propose, what that actually does is it calls create block and add block. Yeah, they're the same. One calls the other. And finally, when you do the deploy, it calls the do deploy gRPC API. So all the client calls that you saw today are just underlying, they're just these gRPC API calls. And yeah, that's...
And I think to maybe address the question somewhat more directly in terms of what I think you were asking about, is we can talk a little bit about the other file that's in here, which is the row types proto. Because this is what's coming back when you do something like listen for data at a name, right? It gives you back the protobufs for Rholang code. So, right, we have par, and par you can think of as just being like the whole Rholang term, which consists of a bunch of things in parallel, right? So a par has a list of things that are sends, a list of things that are receives, that is like bangs and fors, as a list of new blocks, a list of expressions, a list of match cases, a list of private names, which are enforgeable names, a list of bundles, which we can talk about more if people are interested, etc. Right? So par is sort of your top level thing, that's what you get back, and then you inspect the par for the pieces that you're interested in. So if we actually go back and look at the output that we got, if I can still do that, it's a while back. That was,
It should be below that.
just before we did.
I think it's actually the help.
We showed the help twice though. Here it is. Okay, right, so notice here's our par. And in fact, it's a vector of pars because you can have more than one thing at a name. So it's a vector of pars consisting of a single par. And that par itself, remember, has all of those lists that you just saw. So there are no sends, there are no receives, there are no news, as in new name blocks. There is an expression, or there are expressions. So that expression is an expression which is a string which contains hello world. Right? So you can see that if you were interested in pulling data out of this, you would have some post-processing to do. You'd have to take your list of results and say, okay, I expect that there's only one result, so maybe do an assert on the length of the number of results you got back. Take the head and then say, okay, my par, I'm expecting that there's data in the expressions, so then you would look at the expressions field, and then again, maybe you have some validation that, okay, there's only one expression here, and it's a string, and that string is hello world. And if you wanted to see, and notice that there's also a whole bunch more empty vectors after that, because those are sort of the other possible things that there are also none of in this term, because this is kind of a boring term. But you can imagine in principle, especially for contracts, right, the term you get back could be interesting, because it's the continuation, right? It's the body of the contract. So this could have like a whole bunch of stuff in it. We have some questions, I see. So I'll start with you and then go, yep. Go ahead.
I have not seen a way to describe the return structure, or in the hello world, we did not say that it's going to be a string.
We did though. We said it in the contract, right? So the contract, remember if we go back here, to the definition of the Hello World contract, we're returning this string.
Okay, but we haven't explicitly typed it.
Correct. Today there is no explicit type system. It's a string because it's in quotation marks.
Okay, so then if I return a structure,
Yep, you could return anything here. So I could like change this to be, or you know, maybe we'll keep hello world, but I'll like put some braces here, and I'll say that this is in parallel with like for underscore from nil, you know, whatever, right? You can put anything there.
but there's no API that will describe it.
Well, what you get back is the description, right? What you get back includes all of the information about what that thing is. It tells you about all of the sends, all of the receives. You have to parse it yourself, and we don't have a nice parser as of today, but we'll probably write one at some point, just even for our own internal use, and then we'll publish it because it is a really handy thing. Parsing Rholang parsing the ADT is a real pain. But we'll probably publish it in Scala, so if you're using other languages, you know, you'll probably have to still write your own, because it will be a little bit. Yeah, like I say, we're not going to commit to writing any particular parsers in any particular language. Probably some will appear because of our own sort of use cases. We'll maybe put out a bounty for writing parsers, right? This is the whole cooperative bounty program. This is probably like a good thing for a bounty. But yeah, taking apart the AST, this like big par message, and giving useful information is definitely something that people will be interested in. Yeah, totally. So for that, I think what I'm going to do is quickly show you guys the Rholang grammar, and then I'll talk about sort of what that looks like. So I want to do Rholang source. Okay, so going through here. Bundle. I should have grabbed for bundle. I probably should have grabbed for bundle. Let's do that. Okay, so, and I'll scroll down a little bit to bring it up to the middle here. Okay, so a bundle is a type of process. That's what this line means. And these are the types of bundles that exist. So bundles are a way of limiting access to a name, and it's exactly what the registry is going to use under the hood. The registry just sort of like gives you a convenient way of using bundles and exposing part of it publicly. So you can see here there's different types. There's read, write, equivalents, and read, write. And these all correspond to permissions. You can almost think of this as like Linux permissions, like in chmod style. So a write permission, which is labeled as a nice little bundle plus here, means that this is a name that can be written to. Read, bundle minus, is a name that can be listened on, as in I can write a for comprehension over that name. Read equivalents, I can do neither of those things are, however, I can still check for name equality. And this is really good because, in addition, the reason it's called bundle is because you can't pull it apart. You can't look inside and see what is in it. You just have this single bundle, this single atomic unit that you can't take apart. But what's nice about bundle equivalence is you can still check equality. So given two such bundles, I can't inspect them to see if they're equal, but bundle equivalence still holds. So bundle equivalence is great for doing what we've been calling like Diffie-Hellman-like constructions, where basically you each individually have some name that the other doesn't know, and you can create a shared secret from that by putting them in parallel in a bundle together, and you can still check for equality on that. And then read-write is, of course, both. This is basically just a full-fledged name where you can do all of the things you could ever want to do except inspect the internals. So you might do something like this if you, I don't know, for whatever reason want to prevent structural matching on what this is. Maybe there's some sensitive information in there that you don't want people to be able to extract, like some unforgeable name or something. Again, the main feature of this is to take an existing name and split its permissions apart. So if I have an existing name, I can inspect it, I can read, and I can write on it, I can do all those things, but if I put it in a bundle, all of a sudden, well, now I can't inspect it anymore, so I've taken away that permission, and then I could give away the bundle rather than give away the original name. And similarly, if I make only a write bundle or only a read bundle and I give that away, again, I'm giving away something that gives part of the authority, but not the whole thing. So it gives you a nice way of doing OCAPs on names. Does that answer your question? Yeah.
How is this protected, this bundle? You say you cannot take it apart. What allows you to say that?
I mean, you can't take it apart using a Rholang match expression. So to be clear, I mean, you can't bind subsections of it to variables. You can, of course, on the blockchain, just look at it and be like, oh, I see what's in there. But
It's like a private property in a Java program. You cannot
that's right.
read it, but if you go with a debugger, you get it.
Correct. Yes.
Are there any plans to support other programming languages which would allow them to Rholang?
That's a great question. The short answer is no. But again, there have been efforts. People have talked about various things. Rholang is totally open source, very community driven. Like, we would be very happy to see both Rholang compiling into other languages so that you have sort of other backends for Rholang, and also other languages that compile into Rholang so that we sort of can have the blockchain be made available across all sorts of other languages as well. Like, both of these are really interesting, really useful projects that we're happy to give some assistance with, but not something we'll devote resources to ourselves. Yeah. Yes.
So going back to the AST format and protobuf format, and so what is RCON? And is that the right context for the question? Is RCON a serialization format?
So RCON is just essentially using the map as sort of a JSON equivalent. And so I would just say, like, it's, let me just give out I think if we just grab for map. Yep. So you can store any JSON equivalent in a map in Rholang, and you can also do it by using a bunch of sends and paring them together. So let me just give an example. Just rson.text. So if you have, let's say, key 1 here, let's call it key 1, and you have some contents for it, that won't compile, but just as an example. In key 2, you can build your map this way. This was another discussed way of how do you store JSON equivalents. And so I guess maybe the short answer is that RCON was just one way of I guess, describing ways that people can store JSON on the chain, because that seemed to be a use case that people wanted. And so I wouldn't really, we don't actually have an RCON protobuf message, if that's what you were searching for.
Kind of, if
Yep.
RSON was necessary as a DApp developer to know bars to create, it sounds like it's not.
Yeah, because it's not like a officially defined term, or it's not a, yeah, protobuf message.
And it sounds like, you know, JSON is not necessary, although it's conventional and convenient to map between protobuf and JSON
Mm-hmm.
for the convenience of app development.
Yep.
It's strictly not speaking not in regard either. You could interact directly with protobuf or
Yeah, and that's how all of our existing interfaces work, right? It's all through a project called Scala PB, right? Which is just, it takes protobufs and creates Scala case classes instead of JSON objects. And so you can use Scala directly, but you know, I'm sure there's other things similarly for Python and for JavaScript. You are using JSON.
Yeah, also, so if you saw like the RSON demo probably earlier this morning, like all the JSONs underneath were stored as just strings. And so, you know, we were just essentially doing, inside a string, we would actually write out the JSON or like something like this. And then we would then just parse it after we fetched the string off the chain. And this was like, sorry, just to make this complete. We sent this on some name, and yeah, we would just read for this data name and then get back the JSON. Yeah, so all the data bits were stored as, well, our sort of default encoding is base 16, but yeah, you can use base 64. We have this method called hex to byte and 2-byte array, but the hex to bytes is meant for using with base 16. But yeah, everything was stored as strings right now, yep. Right, are there any more questions? Oh, Chris?
So there, I talked about this very briefly in my talk in the last hour, but the idea is that you have a notion of safety, which is information that you gain cannot change your current opinion, and that is with respect to some fault tolerance threshold. So if you ask a validator, what is the state of a name, for example, what data is that a name, they can give you back an answer in terms of a given fault tolerance level. So you can say up to, say, a 50% fault tolerance, like I want to be pretty safe about this. Tell me what is at this name. And so then what they would have to do is go back in their blockchain and look for a block that actually has that level of safety and use that as the basis for which they answer your question, right? Because the answer to your question could change depending on what spot in the blockchain you're at. So they'll go to the most recent block with at least that fault tolerance threshold. But then to address the other part of your question, should you ask multiple validators? The answer there is still yes, right? You should still ask multiple validators unless you trust that one that you asked, right? Like you can imagine that validators could just straight up lie to you. So unless you ask multiple validators, or ask one that you trust, or run a node yourself and ask your own node, right? There's sort of different possibilities here. But the core mechanism is about safety, and whether or not the information about safety you're getting is correct is up to how much you trust the source of it, be it your own node or a validator or a set of validators. Does that make sense?
It does. So if I were running my own node, when I propose the block maybe to a different validator, that node will see the block and it'll have some safety or it'll have a fault tolerance value in that block, and my node can report back the fault tolerance level along with whatever guard allows.
Yep. So, yeah, that would be another form of the API. Is you could ask about the fault tolerance of a given block. You could say, I'm interested in this block specifically because this has a transaction that I care about. What is the fault tolerance of this block? And that would be another question you could pose to validators. And then once that fault tolerance reaches a certain level that you're happy with, then you can act on the data in that block. You can say, oh, this is safe up to a 33% fault tolerance. That means I'm happy with it, and I'm going to act on the fact that, say, this transaction went through, for example, or this token transfer went through.
And so just to clarify, the show blocks API shows the fault tolerance for each block from the view of the node that you're asking the show blocks for. And same with show block. If you give it the hash, it will give you this similar dump, and it will tell you what the fault tolerance value is. And if you query for the listen data at name GRPC API directly, it will return you along with, if you go back to if you go back here, you see data with block info, and you would see along with it this block info without tuple space. And so this is hard to parse, but essentially this value -1 here, this is the fault tolerance that you get back. And so as more blocks get proposed, you should see this value increase up to 1. So those are the tools that you have available right now. Yep.
But the listen event, I would only get it once it's written, and then I'd have to just look for additional blocks if the tolerance wasn't high enough.
So we've sort of wrapped this, for the client, for the RNode client, we've wrapped it such that it streams only on diffs, but the underlying gRPC API is actually a polling one. So if you just continuously query it, it will, as new blocks come up, it will produce whatever you're listening at, or it will produce the relevant data with block info for the name that you're listening at, along with the value of the fault tolerance down there. Yep.
So you can use that then to kind of watch for your, whatever tolerance you have.
Yes.
So in terms of safety, is that measured in block depth or clicks or time or both?
It's the technical measure is in terms of faults. So imagine if there was one trusted node, right? This is a centralized system. This system has instant finality, but no fault tolerance, right? Because as soon as that single trusted source says something, it is de facto true. But if that thing starts lying to us, well, game's over. So what we do here is think about how many validators could stop following the protocol in arbitrary ways before our information becomes potentially incorrect. So the number here is scaled a little bit weirdly on this -1-to-1 scale, but the intuition is that if you're getting a 0.7 number here, that means that up to 30% of the stakeholding validators can stop following the protocol and do random things, and still whatever information it gave you is correct. So it's not about time or block information. It's about truth in the network and protocol following in the network. And that's also true in Bitcoin and Ethereum. It just so happens that block depth is a good proxy for that, right? Because if you think about what block depth really means, you're saying the probability that someone will show up with a longer chain that doesn't include my block is getting exponentially smaller all the time, and at some point we just call it 0 and say, nah, it's fine, it's final. But of course, that doesn't say anything about a 51% attack, right? 51% attack comes in, shoots off this other chain, and your transaction's gone, right? Like.
So in this case, for example, 100% of the validators came in, and there were no additional blocks, and it was, half a second later, you're good.
Totally, absolutely, yeah.
All right, yep.
It's not no, it's the data view parameter.
Mm-hmm.
Why does it use underscore instead of hyphen as other parameters?
Because whoever, we'll do a git blame, we'll find out, but basically the short answer is it's a typo in the source code, and we'll fix it someday. That is correct. So as of today, computation on our chain is free. And as of a month from now, it probably won't be. So, I skimmed over this, I totally ignored this. I didn't mention it at all. But if you actually look at the help, so maybe we'll go back to that again. There are actually more parameters that go into the deploy command than we showed you. So here, right? So here's our deploy command help definition. So we gave only the file name. So which is like not even listed in the arguments because it's a sort of tail parameter. Right? But there are other options here that today you don't have to specify, and in the future you will. Right? So you will have to specify a wallet, which lives at some particular kind of name, and you'll have to specify the nonce for that wallet, and you'll have to say what your gas limit is. Right? We call it flow instead of gas. And you'll have to say how much your conversion rate is from rev in your wallet into flow. So this is very, very similar to what it looks like in Ethereum. And these are parameters that you will have to specify in a coming release. Yep. So we don't really have a good story right now about rent, like apart from sort of the conceptual description of what it looks like. But the high-level answer here is anytime there is data sitting at a name that will probably be considered as renting. So even in our simple hello world example, underscore underscore out underscore underscore is renting space to hold the string hello world.
So renting space to hold the string hello world would be the fact that it was there and now it's possible.
I'll have to look at the source code to give you a complete answer about this, but all operations will have some expense associated with them. So as of today, because we don't have a good story around rent, sending, like creating a send term costs something, creating a for term costs something, the com event costs something, method calls cost something. So in the future, it'll probably still be very similar, where just the act of creating the send will probably still cost something, just to prevent the DOS attack of sending empty data. And then rent proportional to what you actually stored will be on top of that sort of baseline cost.
I'm just wondering, the reason I'm asking is it sounds to me like, that's why I don't understand, that you could gain in such a way where you're using basically listing on a variable as a cheaper way, because you only pay for the full cost to store namespace in your contract, basically.
We can talk about it in more detail after if you want, but there's a long history about this, about who pays for what and why and so on, and I don't necessarily want to get into all those weeds right now, especially since it's not all totally finalized in terms of what we're actually going to build. But in short, I'll just say, in the end, there won't be a way to game the system, even if the cost is in some situations divided unevenly. Yes. Yeah, sorry, dust. I didn't even introduce that term. Right. So the units here, right? Dust per unit flow. This is the equivalent of way per unit gas. Dust is like the way equivalent. So rev is some big amount that can be broken up into smaller indivisible pieces. We've decided to call those pieces dust because we're cute. Yeah, it comes from the rock, right? The indivisible piece of rock is dust. Yeah. Yes.
So if you have an app and you're running your own node, does, as an app provider, and you're paying these amounts, what goes into consensus pool and shared among all the validators versus is any of it recovered by your local node?
So the plan, at least in my head, and Kent can weigh in on this as well, is it'll work like Ethereum. So you specify a limit. Anything in excess of the limit is redirected back and refunded. The fees are sent to the proof of stake contract and then divided amongst the validators using a formula which is published in a document somewhere. And possibly subject to change. But the point is that it's not a selfish situation. It's not that each validator is getting paid themselves. You don't send it, the spent gas cost doesn't get sent to a single validator, it gets sent to the proof of stake contract, and the remainder gets refunded.
Okay, understood. Let me ask the question I was after better. So let's say I'm just reading something off of the blockchain, and there may be some compute involved in that. But it's never going to go through consensus and so forth.
Okay, yeah.
So as a client, I have to pay for that compute.
Well, you would just do it locally yourself. Like you would read, so there's two ways you can think about doing this. You could run a read-only node yourself and do the computation in the read-only node yourself, or you could do like the listening API, pull down some raw data and post-process it yourself. As far as I'm aware, there isn't going to be a service, at least not one that we personally build, which makes validators do some post-processing for you and give you a final result. Some validators might decide to offer such a service, but any compute that is not committed to the blockchain will not be, sort of through the canonical payment scheme. Yeah, read-only nodes exist today. You can make them right now.
So I've noticed we're pretty over time, so thank you for staying around. Yeah, if you have any questions, we'll be up here. So.
Are we 20 minutes over time?